So now let's take a step back and think about how we should see data. So you're probably familiar with this analogy. Data is the new oil, because it came from the year 2000s or something like this, and it works pretty well, right? Data is like crude oil in the ground, and pumping it out is like ingesting data in these data pipelines. Refining data is like refining crude oil into higher petrochemical products. So it kind of works like performing analytics on these data is like processing and refining oil. So it works well, right? It's basically creating untapped value from a raw resource. That's pretty good. But that's the problem. That's wrong. And let me say that again. It is completely wrong because this analogy is backwards. In the oil industry, most of the investment comes for the discovery and collecting and extracting these crude oil deposits from the ground. Is becoming more expensive, and the technology needs to evolve to be able to dig deeper and everything, right? In the data world, collecting data and ingesting data is cheap, and it's becoming cheaper. Moreover, data is growing and there's no end in sight for that growth. Then this analogy also comes with cultural baggage due to the environmental damage that comes in with fossil fuels and carbon emissions. The last point also is that oil can only be used once. The final product is used once and then it's discarded or lost in emissions or anything. With data, the more you use it, the more value it gets. And you can share it, you can reuse it, you can enrich it again, and on and on. So data should be seen as a renewable resource because it's growing. As I said, it's responsible. It can be responsible through thoughtful and responsible use to help and detect cancer early, for example, to help doctors, but also to track and monitor carbon emissions in the industry and mitigate it. It's also cheap and it's reusable. So when we talk about a renewable resource and renewable energy, if we continue this analogy, then we need to address this intermittency problem with the renewable resources, right? In the energy industry, renewables have this challenge where the timing between production and supply and demand is a bit hard to handle. With data, we need to design data pipelines to be intermittent. Why? Because it allows for cost control, efficiency, sustainability, and flexibility. Let's take a deeper look at this. In the cloud, you can leverage several things. First of all, storage and compute are completely decoupled. And with the demand and data and production of data, you have to be, first of all, realistic, right? In the cloud, there's no need to oversize and overperform. Because the cloud is elastic, so you only pay for the storage that you're using. You don't have to have empty disk space ready to be able to store data on it if you need to. So that is true. The point with speed also is that focusing on trying to get the most processed data the fastest way possible to refresh a dashboard that people will look at every 2 hours is not needed. If the processing time for this data is like 5-10 minutes, then maybe there's no need to process data all the time. Maybe we can only process the data every 20 or 30 minutes, and then we still have fresh data when we look at the dashboard, and it ensures that you spend less and it's more adapted to your usage, right? You won't want a Ferrari or a Formula One to drive in a city where you have speed bumps and everything, right? So adapting the performance to your need is essential. And then focusing on quality, make sure there is no redundancy in data, no duplicates. You store it once, you process it once, and then you have a data product that will be reused or shared to another business unit that would need the same kind of data, instead of processing again the same raw data and have another data asset that is very similar to the first one, and then not knowing who created, what happened, where it comes from, right? So then you have to be in the organization collaborative. There's a way to ensure that there's a common framework to share data assets and make sure that every data asset shared are interoperable and compatible. And in the cloud, it's easy to get lost and do everything in parallel to try to build products everywhere. There's a need to prioritize to the products that will bring the most value, and then go on from this. In the production, also in the compute part of the cloud, there's levers to pull to be smart. In the cloud, it's possible to autoscale your computing power. So if a data pipeline needs more machines to process data, it will upscale, and then when it needs less, it will downscale automatically. So you don't need again to oversize. This common data model thing is a thing brought through the sustainability industry in the energy, water world, where these industries try to produce data assets, data products that can be used across the industry, but also across industries, so that when we monitor and track water, energy usage and everything, it can be, joined together and create solutions that are relying on different data sets from different companies and different industries. So this is a common data model, and that can be done at the scale of one organization or an entire industry as well. It's pretty key. And then being sustainable. With the compute and the storage being decoupled, there's also different things. In the storage part, there's like fresh data that you will want to access every now and then, at all times. And then there's data that might be colder, as we say, where there's a need to access and query it and read through the data every once in a semester, every once in a year, or every quarter. So this data doesn't need to be stored on the same storage tier. It can be stored in an archiving tier. And then there's different levels of archives, right? So this process, data lifecycle, can be automated. So once data has not been accessed or queried to be reprocessed for like 3 months or more, it can be switched to another tier automatically. And then the second part of this is the zero cost approach. In the cloud, we don't want to pay for idle time. So there's this serverless kind of approach where we'll only spin up clusters and machines when we need to process data. So when there's a processing pipeline that starts, the machines are spun up. They handle the process, they process data, the data is stored, like the prepared data is stored somewhere else, and then the cluster will shut off. So we only pay for when we use it and what we use. So cloud enable these data strategy and this data transformation journey, and it also drives sustainability through efficiencies, right? In average, according to this study done by Accenture, migrating to the cloud brings about 65% energy reduction and 84% carbon emission reduction through power and cooling efficiency, hardware efficiency, maintaining the servers longer, making sure we only change the parts that are needed and everything, but also through cloud native architecture with the serverless approach, the sustainable software engineering, but also because all the data centers or most of the data centers in the hyperscalers or from the hyperscalers are carbon free and are powered by renewable energy. And this is kind of like the follow-up slide, is that all of the three hyperscaler, Amazon, Google, and Microsoft, have ambitious targets to reduce their emission, power the data centers, but also be more water efficient or water positive. When I say water positive, it's redistributing, for example, the cooling water used in data centers to the network.